So here we are back on Desmos. I've graphed out my x minus 1 function. It's a nice line, it's continuous. Lines are pretty nice examples for these kinds of things. We'll find out sooner that that is continuing to be true as we work through calculus. Let's have a equals the coordinate 1, and b is the coordinate 2. So is the purple function continuous from 1 to 2? Well, yes, it is. It's continuous everywhere. So that looks good. When x equals 1, y equals 0. When x equals 2, y equals 1. Nothing too special there. I'm just evaluating the function at those two different coordinates. The intermediate value theorem says for any y value between 0 and 1, so I'm looking on the y-axis right now, I can find a corresponding x value down here so that the function passes through the exact y coordinate that I want at that x coordinate. So my c would be down here. So for example, I know that the square root of 2 is a number between 1 and 2. That's too big. So let me subtract 1. Now I have a number between 0 and 1. All right, cool. Because the square root of 2 minus 1 is between my two y coordinates, there must be some x coordinate where the graph of my function in purple hits exactly the y coordinate that I want. And it's in between 1 and 2. So I can just find that on my picture. Now, the thing to note here is that the thing to notice here is that my c value, my x coordinate where my function crosses the line that I want, was in between 1 and 2. When I had my y value too large, it was outside of this range. My corresponding x value here is outside of the interval from 1 to 2. So the theorem only works if my target y value is between the two different values of the function. So between 0 and 1. That's when the theorem works. Let's try to look at this at discontinuous functions. So here is my infinite discontinuity. I'm going to pick a equals 0, in which case I get -1/2 as the value of my function, and b equals 3. And I'll get 1 as the value of my function. Now, clearly this function is discontinuous, right? So the intermediate value theorem will not apply here. And just to prove my point, let's watch the mean value theorem fail because it doesn't work on discontinuous functions. The number 0, the y coordinate 0, is between -1/2 and +1, right? There it is. Is there anywhere between x equals 0 and x equals 3 where my function is forced to hit y equals 0? No. It doesn't, because this function is discontinuous. I can do the same thing with my piecewise function. There's a whole bunch of y values that this function just skips. And that means that it has to be discontinuous. Continuous functions do not skip y values as you're tracing your finger along the graph. The same thing with my rational function, where I've got a hole at -1. This function skips the value y equals -2. Continuous functions are not allowed to do this.